So for this FRQ, we've got this particle moving along the x-axis, and we're given a little bit of information. We're given that x of 0 is equal to 2, so at time t equals 0, the particle is right there. That's going to be an important piece of this whole thing. The velocity as well, and keep in mind that the velocity is only for time t greater than or equal to 0, is given to us right here. And what I'm going to do is, actually I already did this, I input that as my y1, and I know we have a t here, but we can put y1 in terms of x. So we're going to change this to x in our calculator, and as you can see here, we've got y1 equaling sine of pi over 3 times x. And just to make sure my calculator was going to give me the exact reading that I needed, I'd put the pi over 3 in parentheses. It would have done it anyway, but it just looks better to me to have it in parentheses. It just gives me a little bit more security there. What I also did, we're going to need this later on, and I'll show you how to do that as well, and I'll show you how to do that one too. So for right now, let's just go ahead and leave it as the sine of pi over 3 times x. That's our velocity, and if we wanted to, we could just graph that velocity over the time interval from t equals 0 to t equals 4, and you can see the velocity is positive for a while and then the velocity is negative. Okay, but the first part of this is asking us what's the acceleration of the object at time t equals 4. Okay, well, if we wanted to extend our window a little bit, let's say we go to all the way to 5, we could do this problem actually a couple different ways. We could calculate dy dx. If you notice, number 6 is dy dx, and we want the derivative at x equals 4. And remember, the derivative of the velocity graph is the acceleration. So we can see right down here, I don't know if you can see that on my calculator or not, but right down there is the cursor. That's the position of the cursor when t equals 4. And we can see the dy dx, which, interpreting the derivative of this function with respect to x, it's since this is the velocity, the dy dx is the acceleration, and the acceleration at time t equals 4 is right here, negative 0.524 if we round to the nearest 3 digits after the decimal. So we would say the acceleration at time 4 is v prime at 4, which is approximately equal to negative 0.524. Okay, so there's our first answer. That's part A, and that part of the answer would get you 1 point just by getting the right answer. Okay, I've got people coming home now, so I'm going to do the rest of this in a second video.